Welcome to Real GMAT Problems, episode 16. Doing real GMAT problems gives us some great opportunities to discuss what test day will look like and feel like. So let's talk through a few examples together. The problems that we're going to do are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually, but I know many of you won't be in that situation. That's completely fine. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions we're working through today. The official guide contains retired problems that have appeared on past GMAT exams, so it's really, really helpful for preparing for test day. I'll give you a chance to work through the solution if you want to on your own, and then I'll discuss my thoughts on the problem and my recommendations for what to take away from each question. What I recommend is pausing after I read through each problem and at the very least, thinking about how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but see how far you can get with a mental solution. It's a great workout for your brain, and it's amazing how well visualizing helps you improve what you write down when you eventually return to the desk. If you're on the go and you have access to pen and paper, like if you're on a train or a plane, that's ideal. This is problem number 53. Of the following, which is the closest approximation of 50.2 times 0.49 divided by 199.8? I'll read that again. Of the following, which is the closest approximation of 50.2, that's 50.2, times 0.49, that's 0.49, and it's that whole product, divided by 199.8, 199.8. I'll give you a moment after I read the answers. Option A is 1 over 10. Option B is 1 over 8. Option C is 1 over 4. Option D is 5 over 4. And option E is 25 divided by 2. Again, recommend pausing here because I'm just going to jump right into the solution so we don't have a bunch of dead air. This is a great problem to discuss on a few levels. The biggest of which is probably how strange it is for a lot of people to estimate on a standardized test. I found that a lot of people are really, really uncomfortable with this, even though the problem explicitly says to approximate. So it's worth discussing that this is a common practice on the exam, and it's also worth practicing a bit so you can get more comfortable with it if you aren't comfortable already. So let's use this opportunity as a way to do both. First, what might a correct solution look like here? Like I've said in past episodes, this problem involves some basic computation, and there's no right or wrong when it comes to how you compute things specifically. I'll share what I would do, but if you have a better path that makes more sense for you personally, that's great. I think when we see 50.2, most of us would think that 50 is both a close approximation and also easier to work with. So I think that's a good bet. Similarly, with 0.49, I think most of us would think that 0.5 is both a close approximation and also easier to work with. So let's make both moves and turn the numerator into 50 times 0.5. Already, I think that makes the problem a lot more approachable. For the denominator, let's make a similar move by rounding that up to 200. That would get us 50 times 0.5 divided by 200. Let's do some computation. 50 times 0.5 is 25. And 25 divided by 100 can be reduced in a few different ways, actually. But ultimately, you'll wind up with 1 divided by 8, which is option B as in beta. And that is the correct answer. Again, there's many ways to execute the actual math here. But the approach is broadly applicable of just like do some rounding, do some math. One quick note to help if you're uncomfortable when you're estimating is note that in the top, I estimated 50 a bit lower than the actual value of 50.2. But I adjusted 0.49 up a little bit to 0.5. And that kind of compensation can sometimes reduce your error rate if you're concerned about that. It's not super important in this specific problem because the adjustments we're making are so small compared to the numbers themselves. The largest relative adjustment here is 0.01 compared to 0.49, which is a 2% adjustment. So this is a pretty acceptable error rate given how spread apart the answer choice is. And there are other questions and other adjustments in this problem that are even smaller than that. But in problems where you might want to make larger adjustments, which can definitely happen on the exam, and that's where I found most people get super uncomfortable, which is really understandable, then that kind of compensation, thinking about that kind of compensation as you estimate can really help you get more comfortable with that. And it also makes it easier to see the answer, usually. So again, just to be super clear, what I'm recommending here is if I adjust something up, then I might want to adjust something else in the estimation down to compensate for that. And that way, my approximation is going to be a little bit closer to reality. So I'll give a quick example. If you're going to round something like 0.45 up to zero point 0.5, then you might also want to round something else down like 0.65 if that's in the problem down to zero point 0.6. Those kinds of compensations can become a little bit more valuable because percentage wise, they're a little bit bigger relative to the value we're adjusting. So hopefully that makes sense. But if you want any help or you're not feeling super comfortable with your decimal multiplication or fraction cancellation skills, we've got a math basics episode on each of those topics linked for you below. Otherwise, if your computation is solid, you probably got this question right. Really interesting point though, just before we move on, 8% of people are going for option E, which is 25 over 2. So I just going to invite you to think about that for a moment. Do you have any idea why someone might do that? That's the result when you do 50 times 50 over 200. So instead of reading the problem as 50 times 0.5 or 0.49, people read the problem as 50.2 times 49. And then they do the rounding of 50 times 50, and then they round up the bottom to 200. So let's just think about that really quick. How might that happen? Well, again, if you read the problem incorrectly, that kind of thing can happen quite easily. So now we're back to a lot of the principles that I've been doing my best to instill over the past episodes. And if you haven't checked those out, I highly recommend them. That's a situation where simply writing what's given and asked, which I've recommended a bunch over the past weeks, can really help out. Like if you just do that quick double check of, okay, did I write down what is given in the problem properly? Oh, shoot, it's 0.49, not 49. Those kind of double checks are so simple but so powerful. So if you're frequently making that kind of mistake, it's a great idea to make the habit of checking your transcriptions. And transcriptions is just a fancy word for what you write down from the screen. And under time pressure, it's just remarkably easy to make those kinds of mistakes. You may have made some already in your practice. I certainly made a almost countless number of them myself. And what I've realized is usually what makes it onto our paper is what makes it into our heads. So a quick double check there can save you a lot of grief because we're usually reading the information from the computer screen. Then we're looking at what we write down and we kind of put our heads down and start getting into the doing math and solving mode, which is totally natural and like not necessarily a bad thing. But if you've made a transcription error, then it's a terrible thing because you're usually not looking up at the computer screen again until you're ready to select the answer. And that can be a difficult moment when you're like, oh shoot, I just am pretty sure I did my math right and my answer is now not on the screen. That can be kind of scary. So just a quick double check before you do the, okay, I'm putting my head down and doing math and computation step of the problem to just make sure that what you've transcribed from the beginning is accurate. I've found that to be super simple and a very high ROI adjustment in your process. If you do that kind of thing, you should avoid pitfalls like option E there, which again, I've said this a bunch of times, but I think it's a really powerful visualization. Imagine 100 of the most talented future business leaders of your generation standing in a room. 8 of them are making that mistake and picking option E. So we're all in this together. Let's fix it together. The more of us who do well on this exam and do well on this exam faster and avoid discouragement and the possibility of giving up, the more time we're going to have to do awesome things with our lives, make ourselves happier, make everybody else happier, make better business decisions, become better leaders, create better businesses, create better products and services for people. I mean, there's a ton of good that we're doing right here. I know a lot of people like look at the NBA and they think it's this really selfish thing. And we're not really here to have that debate, but just in case you're thinking about it like that, I don't necessarily think that's a bad thing because even if you're building a business just for yourself and you want to be as successful as possible for yourself, you're probably going to want to build a good business that makes other people happy. This is just like a very practical, rational thing to do. Now, are there bad actors out there? Sure. But are those the majority of people? No. I really don't think that. That hasn't been my experience at all. It's the vast minority of people. And yeah, we should all think about what we can do to keep that kind of thing from happening and create more transparency in business, etc. But at the end of the day, I just want to remind you that you personally becoming more successful in this process is an awesome gift to the world. And that's the way I'm viewing it. And I really think that's true. And that's why I'm trying to help you out right now. So hopefully you agree. But if you don't, please let me know. I'm always open to feedback and I'm always looking to get to the ground truth of situations. But as I've sought the truth of this situation more and more, I truly believe what I just said. So again, if you disagree with me, let me know. If you have any questions on any of this stuff or you want to provide feedback, just reach out to us anytime. We're at the GMAT strategy on current social channels, and we are contact, CONTACT, at the gmatstrategy.com if you prefer email. Okay, so hopefully you got a good quote unquote note to self from that problem. Let's try another one. This is problem number 54. The average, in parentheses, arithmetic mean of 10, 30, and 50 is 5 more than the average of 20, 40, and what other number? Let me read that again. The average of 10, 30, and 50 is 5 more than the average of 20, 40, and what number? Option A is 15. Option B is 25. Option C is 35. Option D is 45. And option E is 55. Again, recommend pausing here and taking your time to solve the problem. I'm just going to hop into the solution. So real quick note on the whole arithmetic mean thing. The GMAT's really fond of when they mention average, putting in parentheses arithmetic mean. I don't think the why behind why they're doing that is all that important for our purposes here. I think I just want to quickly mention, in case it's not obvious, that the average and the arithmetic mean are exactly the same thing. And when they say arithmetic mean, they just mean the average that you're probably very used to thinking about from all your doing of average computations up until this point in your life. So I'm just bringing that up because I don't want that to throw anybody off. But they very, very commonly put in parentheses arithmetic mean after average. And it just means average. So this is a great question to practice your algebraic translation skills and potentially organizational skills as well. Just in case it's been a while since you've thought about how to calculate an average, the average formula is sum of the stuff over number of things equals the average. So sum of the things over number of things equals the average. So we'll make good use of that here. A great overall framework, if you struggle with word problems and or translating words into math, is to try to break the overall problem into fewer, smaller, more manageable problems. So it's kind of like, okay, I could try to make a grand equation to solve this whole problem in one big move. Or I could break up the problem into several smaller problems, make several smaller equations or parts of equations, and then recombine those later. And I found that latter method to be super, super effective for a wide range of people, especially if you struggle with this kind of thing. Now, if you're not struggling and everything you're doing is working great, then please don't change. If it's not broken, let's not be in the business of fixing it. And I'm never going to argue with your results. If the way that you're doing things is working consistently, please, by all means, get this thing done and move on to the impact and the good stuff that we were just talking about. So I'm going to just give a quick demonstration of how I personally might break the problem into smaller chunks. I do want to be clear, just like the computation thing I was talking about in the previous problem, I think the exact steps I'm using are less important, and it's more the principle of breaking larger problems into smaller chunks that I'm trying to impart to you here. And then I think you can build your own specific methods for doing that. But if you're not comfortable doing that, then you can easily just replicate what I'm doing here. Maybe not easily, I guess, depending on where you're starting, but like you can safely replicate what I'm doing here, and that should work out really, really well. First of all, I'm being asked about a value that has to do with an average. So note that the question is asking me to produce a number that would fit in with two other numbers and then create a certain average. But I don't know what that average is yet. I just know that that average is five less than something else. So I want to find that something else so I can do the whole five more thing and get where I want to go. So I'm almost like logically working my way backwards from what do I need to solve for, or what's my end result, and then what are all the things that I would need to make that happen, and let me just try to build those things up individually. It's almost like a recipe. Like, okay, I want to make a cake. What's the first step? Okay, I need the ingredients, and then I can start combining them. So what's good about that is they must have given me that information somewhere in the problem that will allow me to solve for that average, because otherwise the problem's impossible. And there are no impossible GMAT problems. So that's a good framework, is like, okay, even if I'm struggling to find some information, the information has to be there. There has to be a way to either logic my way into it, or they have to have given it to me directly. So the way they do it here is I'm going to logic my way into it a little bit, mathematical logic. They give me the information in the first part of the problem. So that's where I'm going to begin. And let's just jump right into that. So they tell me that the average of 10, 30, and 50 is something. So I'm going to focus on that small section of the problem just for the moment. And I'm just going to calculate the average of 10, 30, and 50. So another principle that I'm using there, especially if I'm feeling a little bit uncertain about the problem, is okay, there's a lot of unknowns here. What are the things that I do know? What are the parts of the problem that I do understand? What are the things that I feel like I can solve? And sometimes, even if you're looking at a problem and you feel like you can't solve the whole thing, if you can find one section of the problem that you can solve, then solving that one section sometimes can lead you to an insight of how to move forward with the next steps in the problem. So that would be, maybe the analogy there would be like a scavenger hunt, where it's like I got to find the first clue in order to find the second clue, in order to find the third clue, in order to find the fourth clue. Now, if at any point I get stuck with that, I can always just skip the problem and return to it later. But you might be surprised how often just solving one piece of a confusing problem can help you unravel some of the confusion and get you where you want to go. So again, this is more me just trying to impart these problem-solving principles that I think are going to scale well, meaning they're going to apply in a wide variety of situations. And then you can work out the specifics on your own. But again, I'll give you the examples of my specifics if that's more comforting for you. So I'm just going to use the average formula here. Sum of 10, 30, and 50 is 90. I just add those up. And there are three numbers. So I'm going to divide that sum by 3 to find the average. 90 divided by 3 is 30. So I've got the first couple steps of my problem in a good spot. Now, just once again, if you're just getting started with this process and this is the beginning of you engaging with GMAT Quant and you're feeling a little shaky on your math basics because it's been a while since you've done this kind of computation, then check out our Math Basics series and I'll start you from the very beginning, assuming no prior knowledge or very little prior knowledge, and we'll build up from almost nothing to understanding all the basics extremely well. And I highly recommend doing that and then circling back to this series, which is just a little bit more advanced. It's at least one layer above that basic math. So from here, I'm going to look at the next piece of information, which says that the average I just calculated is 5 more than the other average. So this is good news. I'm getting some traction. Now there's a big pitfall here, so just use some caution. 30, the average I just calculated, is 5 more than something else. So what number is 35 more than? It's 25, but the language there and the way that they present that information I've found to be very confusing for a lot of people, and the time pressure that a lot of us feel, I think, really doesn't make that easier in most situations. So 30 is 5 more than 25, but it's very easy to go the other direction and think that it should be 35 and not 25. We'll return to that in a second, but a lot of people are doing that here. So just be careful with those tricky wording situations. Again, I was talking about double checking your transcriptions. In the past, I've talked about writing what's given and asked 100% of the time on math problems. I think both of those very, very simple habits, if you do them 100% of the time, can be just make the whole situation much, much easier. And you're just much more likely to get all the questions you know how to do right. And I think that's just obvious why we would want that to happen. So circling back to the specifics here, that means 25 is the average that I was looking for originally, and that's a great step in the right direction. So now they've given me 2 of the 3 numbers that create that average of 25 at the end of the problem, and I can just move on to that next step, and that's the next segment that I'm going to tackle. So it's kind of like I've split the problem into 3 segments. The first is find the average of the stuff they've already given me. Second is do the five more than thing to find the new average. And then third kind of mini problem I'm solving is, okay, what's the third number that I need to make the average of 25 that I calculated in the first two steps? So I'm just going to use the average formula again to do that. So it's going to be 20 plus 40 plus x I'm going to make for the unknown that we're trying to solve for. And then that whole thing is going to be divided by 3. And again, that's just the average formula. Sum divided by number of things equals average. Now we know the average is 25. We calculated that in the previous step. So on your paper, you would have 20, on my paper, I would have written 20 plus 40 plus x, all that divided by 3 equals 25. And from here, I can just use some algebra to isolate and solve for x. If you need help upskilling or reskilling with algebra, we've got a couple math basics episodes on that for you earlier in the feed. So I would start by multiplying both sides by 3 to get rid of the denominator, which would give me 20 plus 40 plus x equals 25 times 3. And that 25 times 3 would be on the right hand of the equal sign. So on the left side, 20 plus 40 is 60. So I'm just going to rewrite the left as 60 plus x. And on the right, 25 times 3 is 75. So I'm going to have 60 plus x equals 75. Let's subtract 60 from both sides to isolate x. And on the left, 75 minus 60 is 15. Excuse me, on the right, 75 minus 60 is 15. And that gets us our correct answer of 15, which is answer choice A as in alpha, and that is the correct answer. So what are the key skills involved here? Where we've got basic computation, basic knowledge of averages, and the way I solved the problem, some basic algebra. There are other ways to do the computation here, like I said. If you've got those core skills, you're probably at least 80% of the way to getting questions like this on the exam right consistently. But what about that last 20%? Well, this probably comes as no surprise to you, but a lot of people are missing this question. In fact, a full 8% of people pick D as in delta, which is 45. So we'll talk about why that's happening in a second. But also a lot of that extra 20%, like last mile of getting the quant score where you want it to be, comes from not just what you're doing on problems, but how you're doing those problems. So this is why I've just been circling back over and over and over again to how do you read better? How do you write better? How do you keep yourself from making calculation mistakes? Those are really, really big battles that I think are surprising how much those end up impacting a lot of people on this test. Again, if you're not making those mistakes, that's awesome. If you are, hopefully you've been able to leverage some of the advice I've given you, and hopefully you're reducing your error rate over time. So let's go back to D. Why are so many people picking D? Well, if you make a mistake while translating with the 5 more piece that I was talking about before, then you're going to wind up with 35 as the average of 20, 40, and what number? So remember, we started by calculating the average of 10, 30, and 50, which was 30. And then the question says that number is 5 more than the average we're looking for. But if you flip that by accident or you're going too quickly and make a mistake and you do, 5 more than 30, that's 35, which is the opposite way of what you're supposed to do. The actual result is 25, which 30 is 5 more than. But you can see like the way they present that information and word it, it makes it very easy to add 5 to 30. So if that happens, then you're going to do 20 plus 40 plus x equals 35 instead of 20 plus 40 plus x equals 25. And if you do the math correctly there, then x ends up being 45, and that leads you directly to the trap answer, which is D. So that's interesting. Let's dig into that a little bit, because obviously none of us want that to happen, and none of us want that kind of thing to be the bottleneck of business leadership getting better worldwide. I think we could probably all agree that that shouldn't be the bottleneck there. So all we have to do is build a couple habits to keep that from happening. That's it. That's it. You just got to build a couple really simple habits and do them 100% of the time. So what we're back to now is conditioning yourself to be great at execution rather than just knowing math. Yes, you do need to know math. That's why I put an absurd number of hours into that math basics series and refilmed and re-recorded tons of those episodes for you. I want the things I make to work. That's really important to me. I don't want to be wasting anybody's time here. And that's why I asked you for feedback earlier. If you feel like we're not doing a good job or what we're doing is not working, we want to know. So please let us know. But overall, I'm happy to report the feedback has been overwhelmingly positive. So again, highly recommend if you need that math basic stuff. But once you learn that stuff, which is a fairly straightforward process and pretty familiar to most people, once you learn that stuff, I think 99% of the rest of the battle is just execution. So hopefully I've demonstrated how important both of those things, both the math knowledge and the execution are to your success in the quant section in this series. And honestly, I've already made a ton of recommendations about how to translate math well, both in this episode and the previous episode. So I'm kind of just going to take a slightly different angle on this. I'm going to invite you to audit your ability to execute well in general. It's one thing to know what to do, and it's a whole additional skill set to actually do it consistently. And I think all of us could think of many, many situations where that's true in life in general. So if you feel like you can improve in that area, we have got specific episodes linked below on how you can become more consistent with your execution in general, how you can become more disciplined in general, and how you can learn to work smarter, harder, and longer if you're interested in those things. And all those things are going to make you a much better executor on the GMAT for sure, but also other places in life and business, which I think you'll probably find really helpful. I certainly have. And I really recommend implementing the information in those episodes if you find yourself knowing what to do, but consistently struggling to actually do it. If you don't struggle with that, you don't need to do those episodes, perhaps obviously, but if you are struggling with it, that's why we've put an absurd amount of time and energy into making those as good as they can possibly be for you. So I really hope you benefit from that. Just want to say I struggled with that execution stuff so much. I still struggle with it, honestly. It's like a constant daily, hourly, minute by minute battle to be like, okay, what am I supposed to be doing? Okay, am I actually doing it? Oh, shoot, I'm kind of getting distracted by this thing over here. Okay, refocus, refocus, refocus. But the good news is all that stuff is learnable. And if you, like me, have not been good with that in the past for whatever reason, there were tons of reasons I was awful at execution as a young person. Then you're just a few pods and a few weeks of changing your habits away from getting to the next level there. And hopefully you can profit from my many, many mistakes in that arena. If you're already executing super well, like I said, you probably nailed this problem. That's awesome news. If you're looking for something more narrow and specific, then I'll just highlight the mindset that I used at the start of this problem, which is breaking longer problems into several smaller problems. That's like a more narrow way that you can fix your execution on quant GMAT questions specifically. You don't have to become more disciplined in general to get a great GMAT score. It's just helpful, and if you're excited by that, it's there for you. So breaking the problem into smaller chunks, simple but effective way to improve your speed, decrease the energy that you need to solve a problem, and cut down on missing questions you know how to do. Let's work through one more problem together, and let's see what other skills we can build to accelerate your progress here. This is problem number 55. Problem says if y is equal to 4 plus, in parentheses, x minus 3 squared, then y is the lowest when x equals what number? Let me read that again. If y equals 4 plus, in parentheses, x minus 3, close parentheses, square that. So it's just x minus 3 that's squared, not the 4 plus part. So it's y equals 4 plus the quantity x minus 3 squared. Then y is lowest when x equals what number? So it's asking you to minimize y. The answer options are A, 14, B is 13, C is 0, D is 3, and E is 4. All right, so just go ahead and pause if you're still solving. I'm going to hop into the solution here. Great example of a type of GMAT question you're going to see really often on test day, which is it's less about the math, although you do need to understand math in order to solve it, and it's more about the logic and reasoning that you need to do to actually find the answer. And let me demonstrate what I mean. We're looking to minimize y. We got a couple options for doing that. First, we could just plug all the answers in. Honestly, it's not that bad of an approach. It's probably going to be the slowest way to do the problem, but we're virtually guaranteed to get it right as long as we don't make a math error. So it's actually a pretty high leverage strategy. And I do want to make the point that I don't think you should be scared of those kind of brute force approaches. If that's the only way that you can think of doing the problem, just do it. It's totally okay to invest a little bit more time when you're certain that that time is going to pay off. When it's a sure thing, you can afford to invest more. Having said that, it's not the most quick and it's not the most scalable solution, meaning it's not always going to be a great option on future problems. There aren't going to be tons and tons and tons of opportunities to just brute force by plugging in the answers on the quant section. Like there's virtually no way that you're going to be able to solve 50% of GMAT quant questions doing that. Maybe 10%, maybe 20%. This is a good example of that. So again, don't fear it when it can work, but let's discuss an alternative that is a little bit more scalable. So we want to minimize y. Because y equals 4 plus in parentheses x minus 3 squared, we need to minimize both those things. We need to minimize 4, I'll come back to that in a second, and we need to minimize x minus 3 squared. And if we minimize both of those things, then we will have minimized the sum of those things, which means we will have minimized y. Now we can't make 4 any smaller. That's a fixed value. So we're going to concentrate all our energy on making x minus 3 squared as small as possible. So this is what I was talking about. This is more like we're logicking our way through the problem rather than like quote unquote doing math, like solving and isolating for x or something like that. So it's a little bit of an adjustment for a lot of people. This is a little different than the type of math question you might have done in high school. So let's focus on minimizing x minus 3 squared. Think about squaring numbers. What happens when I square a negative number? And if you're not sure, please listen to the exponents lesson that's linked below from that Math Basics series. But think about negative 3 times negative 3. That's positive 9. Think about negative 5 times negative 5. That's positive 25. If we square negative values, the result is always positive. What happens when I square a positive value? It's always going to be positive as well. Think about 4 times 4. That's 16. 5 times 5, that's 25. There's no way we'll ever be able to make that negative. So if we're squaring a number, what's the smallest possible result? You might be thinking something like 1, which is the smallest positive integer. That's a good guess. Or maybe you're thinking like 0.00000000001, or the equivalent smallest positive fraction that you can think of. But if you're thinking like that, let me ask you this. Can you square 0? Again, if you're not sure, please listen to the special cases episode on Math Basics linked below, where we discuss the nature of 0 a little bit more. But you can square 0. 0 times 0 is just 0. And that will always be the minimum value of any number that we can square. Of all the numbers we can square in the world, 0 will always be the smallest. If you're squaring something, squaring 0 will always produce the smallest result. The smallest value that we can square is a highly negative number, like negative a billion or something. But if we square that, it's going to become a really big positive number. So if you want to minimize a squared term, you want to plug in 0. If you're squaring something, the absolute smallest value you can generate is 0. So if we're looking to minimize y, and in order to do that, we need to minimize 4 and we need to minimize x minus 3 squared, and we can't change 4, the minimum we're going to be able to make x minus 3 squared is 0. And then that would generate the smallest possible value of y, which is going to be 4. So now all we have to do is figure out what value of x allows us to square 0. Well, if you need x minus 3 to equal 0, what would you make x? Hopefully you're thinking 3. And that is our correct answer, option D, as in delta. So let's take a step back here. Obviously, that question involves math and a basic knowledge of numbers, equations, and exponents. You can't reliably, consistently get that question right without those concepts or without being the luckiest person ever. But would you call that a strict math problem? I think some people would, but I think a lot of people wouldn't. And it's a typical situation where we just need to do algebra. It's not a typical situation where we need to just do algebra and isolate a variable, like I was saying before. It's kind of more like a logic puzzle, and the pieces of the puzzle just happen to be math related. So circling back, you'll probably see a good amount of that kind of thing on test day. And for sure, there are plenty of pure math questions when you simply solve for a value on the quant section. And we've looked at plenty of those in this series. But how do you improve at this kind of different type of question? There are a few ways, but I think the easiest one to take action on is to just do real GMAT problems and learn from them. And that's a huge reason why we're putting energy into producing this content for you right now. But in simpler terms, it's a good idea to look out for questions that ask you to maximize or minimize an equation that has a term squared. These come up somewhat regularly, probably not every time you take the test, but maybe every 3 to 5 times you take a GMAT, you'll see one of these. So there's maybe like a 10 to 30% chance you'd see one of these on test day. And now you have a nice key for that. If you want to minimize the overall equation, you'll probably have to make the squared term 0. And those kinds of insights, I find it best to have those associated with real GMAT questions. I think that helps bridge the gap between what do I know and what am I getting credit for under time pressure on test day. It's like that building up that pattern recognition. That's what I'm doing my best to help you develop throughout this series. Now, there's other skills to develop beyond pattern recognition, like not missing questions you know how to do, not messing up your computations. And those I think are a little more foundational for people. And so that's why I've led off the series, like really hopefully hammering that stuff for you and making it easier to remember and hopefully easier to take action on. But I do want to start moving into some of this, maybe like the layer right above that of like, okay, if I'm not messing up my computation, like I still might miss questions. What do I do about that? And this, I think, is that next step in your skills stack of being great at GMAT Quant is, this is one of those problems where I got to minimize something and there's a squared term. Oh, I've seen one of these before. I just got to make that squared term 0. If you have that pattern recognition because you have done, seen, listened to real GMAT problems, I think that really helps speed. I think that really helps confidence. And in my experience, it really, really helps the score. So it's funny how useful just that one simple concept is. And there's tons of other like tricks of the trade, if you will, for different types of GMAT problems. And we're going to go through plenty more in this series as we go forward. So please keep joining us if you find this time valuable. But I think that's a great little takeaway from a question like this. So I don't think there's a ton more to discuss on that problem. We talked about brute forcing the problem with plugging in the answers. Don't be afraid of that. We talked about pattern recognition, and we talked about how it's kind of like a logic puzzle. And I just am hopeful that exposing you to those kinds of problems now is going to make it a little bit easier for you on test day because you won't look at that problem and be like, wait, how do I quote unquote do math on this thing? And you can skip to just like, oh, it's one of these logic puzzle questions that Isaac told me about. I'll just proceed with that solution. And I think just decreasing the mental noise that you're feeling frees up some mental resources to be able to actually do the solving part. That's been my experience at least. So as long as you're plugging in numbers, as long as you're okay plugging in the answers when necessary, and you can understand how to minimize squared expressions, I think you'll have a great shot at getting questions like this right on test day when it counts. Like I said before, if you have questions on any of this stuff, feel free to message us anytime at the GMAT Strategy on current social channels or email contact, CONTACT, at thegmatstrategy.com, and we will do our absolute best to help you out. And that includes if you have constructive feedback on what I'm proposing here. If you're like, hey, this sucks for this reason, I'd love to hear from you. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. Imagine cutting your needed study time in half just by watching a 40-minute video. Hopefully you feel like that's, awesome and worth it. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.